Okay, so let's start doing more stuff. So, what do I want next? I think we might look a bit at APL, especially things like bacon. I actually think we have C bacon, right? We don't? C bacon. Oh my, it keeps like redirecting. What the hell? Anyway. Okay, niggas. Okay. Alright, fuck. Uh, um, Man, I'm kind of looking a bit here. Native, generic. Target arch. Flags. RepelX. libffi. EMCCO3. Target arch, target os. Build. Makes me kind of tired sometimes just looking at all these things. Why wouldn't I want libffi? I guess if you don't need it, maybe. RepelXX. So no REPL? Okay. Oh, wow. You can actually target WASI. Compiled by. Oh. C bacon. You could just use Bash or Shell or Python to interpret precompiled bytecode too, I guess. Now you think about it, I could do that. Yeah, so that's kind of how you could do that. Bacon. I think somebody added this to brew, right? Oh, what? Reddit? Oh man, my mouse keeps doing that. I don't know why. It keeps like resetting it or something. Oh really? Did I feel like somebody Starting to get kind of annoying. GNU APL. Okay. Ooh. Bam, not bad. This is bacon. M-lock. Is this the guy that made bacon? JD and dialogue. Closures and namespaces. That's true. I'm not even sure about closures, to be honest. I guess capturing local variables is probably a... Yeah, I mean... Oh yeah, so it could reference the surrounding state as well and have its own local state. Well, if it's just that, I mean, I don't even think we need closures per se. Like, you could have a lambda function, right? But you don't. I don't think you need like a closure. What are functions? Oh. And look at this. Oh, these are the okay. A top over before bind after bind valences choose under. Okay. Wow. Okay. Okay. Shift enter. Isn't that how you do that? Maybe 3 times 1. What? Okay. Interesting. So it's not as simple as just that, I think. Does that work? Crin graph, beacon, voice. I language. Oh, 33.5. Does this work? Oh, I think that's the power of. Okay, that makes sense then. Well, it's not X as much as it's the X glyph. GNU APL I think was pretty good too. GitHub, not Reddit. What? Is that the one? GNU-C compiler. Wow, that's hot. You can add characters? What? Interesting. Oh. Okay. Guess that's pretty good. +3. Is that the 0 plus 3? How does that work? Oh no, 3 plus 3. Okay. Okay. Isn't it just that? Oh, okay. Oh, that has got to be one of the most. That's a third way. Jeez. I mean, at least it works, unlike mine, but yeah. Beacon pad. Oh, good. Oh, okay. Oh, really? I think it has like. Oh, it has is real time as well. That's nice. That's really good. The Bacon Pad is actually. Can I download this locally? Bacon Pad. Okay. Mechanized systems. Dun, 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 dun. That is actually pretty good. Fog. You can see there's a lot of different ways, but the problem is they're kind of static glyphs. Strand. Like, I have no idea what that even means. Strand operator? Like, what is that? What even is that? Stranding. Decompose. Yeah, I think I'd rather just use English to do that. So that's probably at least something like that, right? And the extra parentheses, I guess it could get kind of annoying, especially if you have too much of it. But I think it does like allow you to delimit things properly, and at least for humans, I think it's actually a good thing. Instead of having to, because it makes it very clear up front exactly what's kind of doing what. Again, you could probably like resize the parentheses and reduce them as well. I think that's what I'm going to think about in the IDE. But yeah, so that's kind of how they do their thing, and I think point free Haskell is kind of similar. So, yeah, I think that kind of makes sense, right? We go on Jupyter, we could kind of check some of this out. What's Haskell? Google. Oh, really? Hmm. Wait. Zero sum. So. Oh, they mean like just zero? Oh, they mean like zero sum? Wait, what? I don't know what the fuck that means. Why would it have yeah, but I guess you can see it kind of works, right? So instead of having to specify the argument and then re-specify it again, like clearly what this is doing is that it's applying full dar to the rest of the list, and so you could probably you could specify it like implicitly. So I guess this would be kind of one function composition thingy. By doing so, though, I guess you would still want to have like basic types, because that otherwise it could still have like yeah, I feel like you could still change the way that works. I guess you would still what do you call it? You would still explicitly specify the typing for it. So you would still say it takes in XS and returns SX. Just that in the definition body itself, you don't have to kind of redo that, I guess. Especially for something as simple as that. And you're only doing like declarative function composition. Yeah, and again, if you do it unwisely, I guess it could. I mean, anything could anyway. So it's like, we probably already do with imperative programming anyway. So I think it's probably better to have something that's a bit more obfuscated in functional or declarative programming land than in imperative programming land. And again, I guess it's kind of the same idea where you just don't want to look at a whole bunch of stuff. And one of the things I always kind of point to is things like the Prolog compiler. Let's do Prolog. If you look at some of the code, it's absolutely insane. I would say it's just like it works, I guess, but I mean, libbf libty. Maybe it's in lib, not source. CLP. So yeah, stuff like this, I guess. That's that's the actual library. So yeah, the implementation would probably be in source of packages. Packages. Oh, I guess that's more like contrib then. Yeah. They have their stuff here, I guess. And if you go into like literally any one of them, there's just a lot of stuff. And again, this isn't to like to be negative about it or anything, but or to kind of because Prolog is a good language, right? And SWI Prolog actually does work and is actually pretty good for what it does. But look at the things that you have to do to kind of implement just even some of like the simplest stuff in imperative programming, where you're just checking half the time. You're assigning, checking if null, if you're doing for loops, and you're freeing up memory, and then you're checking. You have a bunch of if statements. There's tons of if statements. checking for certain things, like if it's the same thing as the buffer area, same thing as the string area, then you would free your memory again. And I think there was one about arithmetic. Arith. Oh, this is just the header file, but in the definition file, source file. Yeah, and even something like this, predicate implementation, I guess. Like, you just look at how much code you have to dedicate just to kind of like declare your state, and then the switch, I guess, is probably pretty nice. It's kind of like pattern matching. But even in your statements, again, you're declaring stuff, you're checking stuff with if statements, and if on certain conditions you might return an error early, or if something's false, then maybe you have to clear it and fail, etc. So again, you can kind of see just this way of programming. I guess it works, but I feel like you really just don't have to do this. Especially with the ideas that are now possible, and I mean, like, not just the simple stuff, not simply like just changing up things a few bit and cutting out a bit of code and making it a bit more clean. I'm saying like a complete kind of rewrite of, or kind of rethinking actually of the entire scheme. So instead of having something like this, you could probably write this in like 4 lines of code, and each line wouldn't even be that big either. And again, it's all about composing your functions properly and setting them up properly, and thinking about that, thinking declaratively and functionally in the first place, right? So thinking about composition, composing things together, transformations together, and how the data will look like as it gets transformed, and thinking about how you can then, pipe that into different parts of the program, how different functions interact together to produce the output that you actually want. And I think that's just way more. I mean, it might require a bit more kind of upfront thinking and planning, but I think it's just way better than kind of just going into it and just doing it imperatively and from scratch. And again, we look at a specific. I saw there's a specific one where it's like, yeah, I mean this isn't too bad. Compare numbers, but there's one where you have add or you have subtract, which could be a bit of a problem. But yeah, PAL. Maybe even something like the PAL. Again, if you're just kind of raising something to the power of something else, it's like, does it really warrant all this code? And then you're gonna maybe create some kind of macro for it. I think this isn't actually too bad, to be honest. It's kind of like saying PAL is defined as CR_PAL. But again, you're declaring your state. You're doing, like, this is the actual logic here, I guess, where you're just like doing PAL. And PAL, I guess, is just a C library function in standard math or something. And then it's like, oh, okay, well, then you got to check whether the result is actually valid. If it's nan, then that's a bit of a problem. Now you got to, like, okay, well, what kind of problem is it? If it's like upward, downward, or towards 0, then you got to, like, set the actual result you want. And then, and this, like, extra break, it's just whatever, I guess. Round mode, FE to nearest, F reset, FE set round mode, and now you're returning the result. So it's like, oh, yeah. So I think that's should give us an idea of what kind of issues in programming we have nowadays, and really just how messy everything can really be, and how how clean it could be if you kind of think about it right in the first place. And this is what we're going to try to kind of do, is we're going to what I kind of like doing is I kind of like applying this in the entire kind of field if possible. And I feel like, well, I mean, I guess it's kind of just more of a feeling, but I think it's honestly very possible and very practical to actually kind of redo it. The upfront kind of action potential and getting there will probably take a while, but the idea is kind of similar, where you saw something like that where they're doing all of that state management, they're doing all that checking. Instead, you kind of wrap that around in things like algebraic effects. You simplify everything so that you don't explicitly deal with variables or state, and you're always piping state. So you don't really necessarily have like a global state that you're modifying, even though maybe underneath the hood it's kind of like that. The API or interface that you're actually dealing with is just transformation of state and passing of state. So you take in some state, you modify that, and then you return that state, modified state. And the way that's going to compile and be represented on the actual hardware will be quite deterministic and quite efficient. And that's kind of the idea. Of course, getting there is actually a different story. Alright. But looking at Haskell, though, I think I'm going to have something like that, where we have a function declaration plus our types and generics, plus our definition, and if possible, do it in as few kind of words or characters as possible. Probably words, I'd say. Characters are probably not too bad. So the more the more specific the character set might be actually okay, at least up until a certain point. So again, we're looking for something like an access. So I think what I'm going to code in next is the ability to have complex data. I removed it last time, but what do I want to do first? Do I want to have complex data where you could have multiple layers and or do I want indirection? Yeah, because I think I also want to code in indirection. By indirection, I mean A is int or A. Here, int and string refer to kind of indirect things. So A becomes a spec rather than a a constant. And then you could have multi-layer constants. Or multi-layer specs, right? And if you have a spec or a struct, that's going to mean you're going to have to instantiate that or kind of treat it as an actual thing. So the thing we have right now is we have we're only passing in kind of constants, and our functions, we don't even have like functions per se. I mean, yeah, we can't really like run a function. Let's say we want to run a our custom function. And that just returns an int of 3. So that's going to return a spec, right? So I'm going to code in a spec, I think. I'm not entirely sure. I mean, maybe I'll just make this a type for now. And I'll just make this a vector of val. Vector of spec or vector of val. Or maybe I could have an enum. So this will allow me to have indirection and a base type, which I'll call the base case, and the recursive case. And the recursive case, you know, that's going to match, you know, what I just write, kind of this kind of thing, right? So it'll kind of have a. And then you'll have a recursive case containing 2 specs. And these specs will just be values into a string. There is a bit of a problem though, because I haven't coded in strings yet either. So I think I might code in strings. Oh, damn it, man. Where the hell is val? We wanted to own it, so... Okay, I think we can just add it. Pretty sure it still works, right? Let's try the test. Okay. It's pretty good to me. So, make a spec, and then we need a way to kind of dereference that stuff. So you can't, like, if you try to (1a) and you just try to add them together, that's going to fail. That's probably going to fail. Or you could do default implementation. And let's actually use the function name, not the operator. Is element-wise addition. So what it'll do is it'll kind of go down each level, it'll add it, and it'll create a new spec. Create a new spec with element-wise operation. Addition. So that's kind of what we'll do. Later on we could kind of add a bit more stuff. Did we do this properly? Params. I don't think I'm going to have types just yet. But I think I do have to add the types in. That's how I can get the hash table properly. Oh, damn it. Yeah, I think I have to do that. Where's the hash table? The env. Control T and so instead of just string, we'll also have a definition. Could do that. If we do that, we'll be able to kind of like have multiple different things of the same thing, but I think we don't need that for now. I think I'll just comment this out. But the idea is, look, you know, we can maybe a function direction or something, or indirection. So it basically points to something. Point to another value. Env field. Okay. I'll add call with X later on, but for now, I think we're going to focus on spec and element-wise operations. That way, but wait. So maybe what we'll do is we can match data with spec. Yeah. So what we're going to do is we're going to change data into spec. Here, fields. This is going to be, in fact, a spec. Yeah. Guess we'll have to change quite a bit of things here. I think I'll go to the library now, though. See what we can get. But yeah, I think that's pretty cool. And really, like, fuck imperative languages. Fuck imperative languages. C, Java, C++. Yeah, they're really shit languages. I think I just had to say that, get that out there. Like, nothing against their creators or the community or anything, but in this society, modern society, 2023, you know, I think we need to evolve past that, especially with more data and stuff like that. And yeah,